If you've ever searched for gold or spent time around creeks, hillsides, or old workings, there's a strong chance you've already walked away from real gold without knowing it. Not because the gold wasn't there, but because of one natural misjudgment that almost everyone makes. Today I'm going to show you what that misjudgment is, how it forms naturally, and why it causes experienced people to leave gold-bearing ground too early. This isn't theory. This is based on geology, erosion, and real field behavior. By the end of this video, you'll understand what to stop ignoring, what to stop chasing, and how to read the land the way professionals do, so your time, effort, and decisions actually make sense. Let's start with the mistake itself. The most common reason gold is missed is assuming that visible signs must look gold-like. Bright colors, quartz veins, obvious heaviness, shiny material. Most people unconsciously believe if gold is here, nature will make it obvious. That assumption is wrong. Gold is not found because nature highlights it. Gold is found because nature hides it among ordinary conditions. And the misjudgment is this: people leave areas because the surface looks unproductive, when in reality, productive ground often looks exactly like that. Let's be fair. This misjudgment doesn't come from ignorance. It comes from pattern learning. Humans are trained to look for contrast, look for color changes, look for standout features. So when someone walks into an area and sees dull gravel, uniform rock, no obvious veins, no color excitement, their brain says, there's nothing special here, and they move on. That decision feels rational, it feels efficient, but geology does not work on visual excitement. Gold does not follow beauty. Gold follows process, specifically pressure, heat fracturing, transport, deposition. Gold ends up where movement slowed, not where the land looks dramatic. This means gold is commonly found in places that appear washed out, broken down, boring, repetitive, unremarkable. And this is where the misjudgment causes damage. People mistake lack of visual signal for lack of value. Let's talk about what gets ignored most often. Ordinary creek bends, uniform gravels, weathered hillsides, old filled-in channels, areas without exposed bedrock. These locations don't excite people. They don't photograph well. They don't feel rewarding to inspect. So people rush through them. That's the mistake. Because gold doesn't care about your excitement level. Gold cares about where water slowed, where weight settled, where material accumulated over time. Professionals don't ask, does this look like gold country? They ask, where did material move from? Where did it slow down? Where would heavy material naturally stop? They study slope changes, gravel consistency, rounded versus angular material, layering, packing density. To an untrained eye, it all looks the same. To a trained eye, it tells a story. Here's something most people never consider. The surface often lies wind, rain, floods, freeze-thaw cycles. These processes rearrange the top layer constantly. Gold, being heavy, sinks. So the cleaner and more boring the surface looks, the more likely heavier material has already dropped below. People leave because nothing is showing. Professionals stay because nothing is showing. That difference matters. Let's address quartz, iron staining, and color. Yes, these can be associated with gold, but here's the problem. They are common, not exclusive. Quartz exists everywhere. Iron staining exists everywhere. When people chase these signs blindly, they waste time. When people dismiss areas without them, they miss gold. The misjudgment is thinking presence of indicators matters more than geological context. It doesn't. Gold favors time, not excitement, not effort, not movement. Time. Older, slower systems accumulate gold. Fast, dramatic systems scatter it. So the places that look quiet, stable, unchanged, repetitive are often the ones worth attention. And those are the exact places people leave first. This misjudgment doesn't just cost discoveries. It costs fuel, energy, equipment, where motivation. Confidence people jump location to location, always chasing the next better-looking spot. Meanwhile, the gold stays where it always was. Underground, they already walked across. This is how people stay busy and stay broke. Here's the correction. Stop asking, does this look promising? Start asking, does this location make sense? Evaluate. Direction of movement. Areas of slowdown, changes in slope or width. Consistency of material. If the land makes sense, ignore how boring it looks. Almost everyone leaves right before they should stop. They leave when results aren't immediate. The surface looks repetitive. Nothing new appears visually. That moment is critical. Professionals slow down there. Amateurs speed up. Gold doesn't reward urgency. This misjudgment affects beginners and veterans alike. Experience can actually make it worse. Why? Because experience builds habits, and habits rely on visual shortcuts. If those shortcuts are wrong, experience reinforces the mistake. Only deliberate evaluation breaks it. Let's be clear. Correcting this misjudgment does not guarantee gold. What it does reduces wasted effort, increases meaningful testing, improves decision quality, builds long-term understanding. This is how professionals operate, not emotionally, not visually, but logically. This skill transfers the ability to ignore surface appearance, evaluate underlying process, stay when others leave. That applies to prospecting, investing, land evaluation, opportunity, recognition. Gold just makes it visible. Let's summarize plainly. Most gold is missed because people expect obvious signs judged by appearance. Leave boring ground too early. Gold is found by those who understand movement, respect time, ignore excitement, trust process over appearance. That's the difference. If this helped you think differently, make sure you're subscribed. This channel is about practical understanding, not hype, and every video builds on the last. If you've spent time around rock, creeks, or old workings, let me know in the comments what you were taught to look for, and whether this changed how you see it. And if you want more videos like this, calm, clear, and focused on what actually matters, stay with me. There's more you haven't been shown yet. Experienced prospectors don't miss gold because they lack knowledge. They miss it because experience changes how the brain filters information. That's the part most people never talk about. When someone has spent years around creeks, hillsides, dry washes, or old workings, they don't look at the ground the way beginners do. They don't scan slowly. They don't question every surface. Their mind categorizes what it sees almost instantly. And that's where the problem begins. Experience builds mental shortcuts. Shortcuts save time, but they also discard information. An experienced prospector arrives at a location and within seconds has already decided whether it's worth attention. Not consciously, automatically. The brain says, "I've seen this before. This isn't it. Nothing new here." And they keep walking. The mistake isn't ignorance. It's premature certainty. Gold is missed not because it's invisible, but because it's dismissed too early. Most experienced prospectors don't realize how fast they're deciding. They believe they're evaluating carefully. In reality, they're filtering aggressively. Years of exposure teach the brain to prioritize certain signals and ignore others. Veins, color changes, iron staining, exposed bedrock, sharp contrasts. These become approved signs. Anything that doesn't match that internal pattern is quietly rejected. This is efficient. It is also dangerous. Because gold does not obey personal pattern recognition, it obeys geological process. The land doesn't care how many seasons you've worked it. It doesn't care what you've seen before. Gold accumulates where conditions allow it, not where experience expects it. Experienced prospectors often walk faster than beginners. They cover more ground. They trust their judgment. They don't linger where nothing stands out. Beginners stop too often. Experts stop too selectively. And that selectivity is exactly why gold gets left behind. Many experienced prospectors believe they are reading the land. What they are often doing is confirming what they already expect to see. Confirmation bias is subtle. It doesn't feel like bias. It feels like confidence. You look at a stretch of creek, no exposed bedrock, no obvious heavies, uniform gravel. The mind concludes, transported material, nothing settled here. But that conclusion skips steps. Gold doesn't require exposed bedrock to settle. It requires energy loss. Energy loss happens in many quiet, visually unimpressive ways. A slight change in gradient, a widening channel, a compacted layer beneath loose gravel, an old flow path buried by later movement. These features don't shout, they whisper. And experience teaches people to stop listening to whispers. Another reason experienced prospectors walk past gold is overtrust in efficiency. Efficiency becomes a badge of honor. I don't waste time on dead ground. I know what I'm looking for. I can tell within minutes. But efficiency is only valuable if the criteria are correct. If the evaluation system is flawed, efficiency simply means you miss things faster. Gold doesn't reward speed, it rewards correct interpretation. Many experienced prospectors pride themselves on how quickly they can eliminate areas. That skill is only useful if elimination is accurate. Most of the time it isn't. Gold is often present in amounts too small to announce itself on the surface. It accumulates slowly, incrementally, and quietly. It doesn't advertise, which means the places that look unproductive at first glance are often the ones that require confirmation, not dismissal. Experienced prospectors tend to sample less than beginners. They believe they don't need to test as much. Beginners pan more. Experts judge more. Judgment replaces verification, and gold hides in that gap. Another factor is over-attachment to previous success. If someone has found gold in a specific type of environment, certain gravels, certain colors, certain formations, that environment becomes their internal model. They unconsciously search for similarity instead of logic. So when they encounter a different-looking area, even if the processes are correct, it feels wrong. They say things like, "This isn't my kind of ground. I've never found gold in places like this." That statement sounds reasonable. But geology doesn't care about personal history. Gold doesn't repeat itself for your convenience. Every region expresses the same processes differently. The physics are consistent. The appearance is not. Experienced prospectors often confuse familiarity with correctness. Familiar ground feels productive. Unfamiliar ground feels risky. So they stick to what looks right, even when it isn't. Gold is missed because experience narrows vision instead of sharpening it. Most people walk past it without a second glance. A bright metallic shimmer in the dirt. Sharp crystal faces catching the light. To the untrained eye, it looks like gold. To experienced prospectors, it is dismissed with a single phrase that has discouraged generations: fool's gold. But what if that name has caused more missed discoveries than any other mistake in modern prospecting? Pyrite is not the enemy of gold. In many of the richest gold districts in the United States, pyrite is the first signal that something far more valuable lies nearby. The problem is not pyrite itself. The problem is misunderstanding what it is trying to tell you. Gold does not announce itself loudly. It rarely appears where people expect it. Instead, it leaves geological signatures, chemical associations, and structural clues that only become obvious when you stop treating pyrite as a disappointment and start reading it as data. In advanced mineral exploration, pyrite is not ignored. It is mapped, analyzed, measured, and tracked. In some cases, entire multi-million-dollar gold discoveries begin with nothing more than scattered iron sulfide crystals in otherwise unremarkable rock. To understand why, you have to step back, far back from the pan, the river, and the surface shine, and look instead at the conditions that create gold deposits in the first place. Gold forms deep within the earth, transported by hot, chemically charged fluids, moving through fractures in the crust. These fluids do not carry gold alone. They move with sulfur, iron, arsenic, quartz, and other elements that react to changes in pressure, temperature, and chemistry. When conditions shift, minerals drop out of solution in a predictable order. Pyrite often forms first. Gold frequently follows. This is why pyrite appears in nearly every major gold-producing region of the United States. From Nevada's Carlin Trend to California's Mother Lode, from Alaska's lode systems to Colorado's mineral belts, pyrite is not a coincidence. It is a byproduct of the same hydrothermal systems that transport gold. But not all pyrite is equal, and this is where most prospectors fail. The shape, texture, location, and alteration of pyrite matter more than its shine. Cubic crystals growing freely in sediment may mean nothing. Fine-grained pyrite locked inside quartz veins tells a very different story. Disseminated pyrite spread through altered host rock signals, yet another geological environment entirely. In high-value exploration, pyrite is classified, not dismissed. The first distinction professionals make is whether pyrite formed in a high-temperature or low-temperature system. High-temperature pyrite tends to be coarse, well-formed, and often associated with intrusive rocks. These environments can host gold, but not always in economic concentrations. Low-temperature hydrothermal systems, on the other hand, often produce fine, microscopic pyrite that forms alongside invisible gold particles. This type of gold does not glitter. It hides. In Nevada, some of the most profitable gold mines in history produced gold that could not be seen with the naked eye. The only surface clue was altered rock dusted with pyrite and stained by iron oxides where weathering had begun to break it down. This brings us to the first step in decoding pyrite as a gold signal: understanding oxidation. When pyrite is exposed to oxygen and water over long periods of time, it breaks down. The sulfur escapes and iron is left behind, staining the surrounding rock red, orange, or yellow. These oxidation zones are not random discolorations. They mark pathways where mineralized fluids once moved and where gold may have concentrated at depth. Experienced geologists pay close attention to these iron-stained zones, especially when they align with fault systems, shear zones, or contacts between different rock types. Gold prefers structure. Pyrite often marks it. The second step is texture. Pyrite that appears as isolated crystals in loose gravel is rarely significant. Pyrite that is finely disseminated through quartz, schist, or altered volcanic rock is far more important. This texture suggests long-lasting fluid flow rather than a single mineralizing event. Gold needs time and repetition to accumulate. In advanced exploration, even the grain size of pyrite matters. Fine-grained pyrite has a greater surface area and is more likely to trap microscopic gold particles within its crystal lattice. In many modern gold operations, gold is recovered not because it is visible, but because it is chemically locked inside pyrite itself. This is why pyrite is sometimes processed, not discarded. The third step involves location within the landscape. Pyrite found high on ridges, near exposed bedrock and structural intersections often indicates proximity to the source of mineralization. Pyrite found far downstream, rounded and water-worn, may still be useful, but it tells a different story. It suggests erosion from a mineralized zone upstream, narrowing the search area rather than ending it. In professional surveys, pyrite is used as a pathfinder mineral. Its presence helps geologists trace fluid pathways back toward the original gold source. This is the same logic used in oil exploration, groundwater modeling, and geothermal studies. Gold exploration follows physics, not luck. Another critical factor is association. Pyrite rarely acts alone in gold-bearing systems. It commonly appears with quartz veins, altered host rock, arsenopyrite, chalcopyrite, or carbonaceous material. When pyrite occurs alongside quartz veins that cut across existing rock layers, the probability of gold increases dramatically. Gold favors cross-cutting structures. These fractures act as highways for mineralizing fluids. Pyrite is often the roadside sign telling you the traffic once passed through. This is where many amateur prospectors make a costly mistake. They see pyrite and move on, assuming the area has already been fooled. Professionals see pyrite and slow down. They measure strike and dip. They examine wall rock alteration. They follow the structure laterally and vertically. They sample systematically rather than emotionally. In the United States, regulatory filings from gold exploration companies repeatedly show the same pattern. Initial surveys identify pyrite anomalies first, followed by detailed geochemical testing, and finally gold confirmation at depth. This process is not guesswork. It is repeatable. The final misconception that needs to be dismantled is the idea that visible gold is the goal. In modern high-value gold exploration, visible gold is rare and often economically insignificant. The real value lies in consistency, scale, and geological predictability. Pyrite offers all three. When decoded correctly, it does not fool anyone. It informs. And in the next part, the focus shifts from recognition to decision-making. How professionals determine when pyrite is worth following and when it should be ignored entirely. How chemical testing, structural alignment, and regional geology separate real opportunities from endless wasted effort. And how some of the largest gold discoveries in American history began with nothing more than iron sulfide crystals most people walk past. Once pyrite has been identified as potentially meaningful, the real work begins. This is the stage where professionals separate promising ground from geological noise. The difference is not experience alone, it is method. The first professional filter is chemical behavior. Pyrite associated with gold rarely exists in isolation. It alters the surrounding rock in subtle but measurable ways. Silica increases, carbon content shifts. Trace elements like arsenic, antimony, and mercury begin to appear in patterns that mirror gold deposition. These elements are not contaminants. They are fingerprints of the same hydrothermal fluids that carry gold through the crust. In advanced exploration, pyrite becomes valuable not because it sparkles, but because it reacts. When broken, crushed, or weathered, gold-bearing pyrite often releases faint sulfur odors, produces iron oxides rapidly, or shows microfracturing under magnification. These reactions signal instability, an environment where gold had the opportunity to precipitate and become trapped. The next step is structural conformation. Gold does not spread evenly through rock. It concentrates where stress was highest. Fault intersections, fold hinges, shear zones, and lithological contacts are the preferred traps. Pyrite that aligns with these features is not random mineralization. It is directional information. Professional geologists map pyrite occurrences the way investors map market trends. One isolated signal means nothing. Multiple aligned signals form a corridor. Corridors form targets. In the United States, some of the most profitable gold systems were identified not by gold itself, but by long, continuous pyrite-bearing structures that cut through favorable host rock. When these structures repeat across miles, the probability of economic gold increases exponentially. This is where surface observations meet subsurface logic. Pyrite found in oxidized zones near the surface often indicates that deeper, unoxidized sulfide zones remain intact below. These deeper zones are where gold is best preserved. In many cases, surface iron staining is merely the weathered shadow of a much richer system beneath. Modern mining operations routinely invest millions based on this principle alone. Another critical indicator is pyrite deformation. Pyrite crystals that appear crushed, stretched, or smeared suggest that mineralization occurred during active tectonic movement. This is extremely important. Gold is most efficiently deposited when fluids move through rock that is actively breaking and resealing under pressure. Static rock rarely hosts significant gold. Deformed pyrite is evidence of movement. Movement is opportunity. Professionals also pay attention to what pyrite is not associated with. Pyrite formed in sedimentary environments without structural control, alteration halos, or silica enrichment is usually barren. Shiny crystals in soft rock, unconnected to veins or fractures, are often misleading. This is the pyrite that earned the name fool's gold. Real pyrite indicators demand context. Context is everything. This is why advanced gold exploration relies on layering information. Geological maps, satellite imagery, geochemical sampling, and physical observation are combined into a single narrative. Pyrite becomes one chapter, not the entire story. When pyrite aligns with favorable host rock, strong structure, chemical alteration, and regional mineral trends, it stops being a nuisance and starts becoming a guide. Some of the most valuable gold discoveries in North America were made decades after initial prospecting because early explorers dismissed pyrite-rich ground. They were searching for shine, not systems. Today's high RPM gold knowledge is built on systems. For serious prospectors, investors, and geological thinkers, pyrite is not a failure. It is a question. And the right questions, asked in the right place, lead to answers that change outcomes. Gold does not reward impatience. It rewards interpretation. The ground speaks in minerals. Pyrite is one of its loudest voices, but only if you know how to listen. Gold is rarely found by chance. It is found by those who understand what the land reveals before the metal ever appears. When you stop chasing glitter and start reading geology, every outcrop becomes information, and every signal brings you closer to the truth hidden beneath your feet.